The Future of Blazor and WebAssembly with Steve Sanderson.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company empowering .NET teams to be self-sufficient and able to deliver world-class results. They are hiring architects and .NET engineers who'd like a path to become an architect, so you can go to clearmeasure.com/careers for that. Today, I have a repeat guest on the show, Steve Sanderson, and he was a guest back in September of 2020 on episode 106. He's working as a developer for Microsoft in the team that brings you the ASP.NET technology stack, and lots of other web things, and doing lots of work with Blazor and WebAssembly. Previously, he developed .NET software as a contractor for clients in Bristol and beyond. He's also wrote some books for A-Press, such as the very popular Pro ASP.NET MVC framework. And from time to time, he speaks at user groups and conferences, and recently been running a bunch of training courses on topics like C#, SQL Server, and ASP.NET MVC. He's been speaking at a lot of NDC conferences, and he's been instrumental in some very visible projects. He started the Knockout.js project back in 2010. It was an early JavaScript UI framework, and he was also on the Azure Portal team. And of course, anybody using the Azure Portal benefits from that work. So, Steve, welcome back to the show. How are you, sir?
I'm great. Thank you, Jeffrey. It's really nice to chat to you again. Absolutely.
Tell you what, you've been really busy, judging just from the conference and speaking schedule that you have, and of course, anybody, if you're just meeting Steve for the first time, I do encourage you listeners, just Google and search for presentation recordings. There's a ton of material out there because of all the speaking, but there is a lot to get into, and you've been instrumental in Blazor and WebAssembly and so much going on in that space. But before we dive into that, just so the listeners can kind of get to know you a little bit, what are the big changes and curves in your career that kind of steered you in this direction, working on the stuff you're working on these days?
Interesting question. I suppose it depends how far back you go. I don't think when I was at university, I necessarily intended to be a software developer. I probably thought I was just as likely to go into some sort of financial career or something. That probably was what I would have expected at that time.
Okay.
But yeah, I came out of university and got a job with some friends who had a small startup that were building a software as a service product. And that was built on VB.NET. So that's when I first got my exposure to the Microsoft developer technologies and .NET. And then, I guess I followed it through from there. The biggest pivot that happened after that, I suppose, was the appearance of ASP.NET MVC, which happened to come out at a point in time when I was looking for a change of job. So that's why I decided to write a book about that. And then that led into me working at Microsoft. So I guess those are the main steps that got me into this company. And then from there on, I've kind of stuck to the web part of things and bounced around a few different web-related projects. And I guess lucky for me, the web has remained the dominant technology in the whole software industry throughout that time, and it's not shown any signs of slowing down. So I'm still following along with that.
Okay. And now this is, I guess, ancient industry history now. What was it, 15 years ago, maybe 16 years ago? The original prototype for ASP.NET MVC was done by Scott Guthrie while he reportedly was on an airplane, just kind of jamming some code.
Debunked.
Don't
theory.
let me debunk theory.
That did not happen. But yeah, carry on.
Well, I'm okay. Who do you know who, like, were you the one who originally played around with what became Blazor? Or what was the actual genesis, and what was your part? Because you played a huge role in Blazor coming to bear now.
Sure. Yeah. Okay. Well, Blazor derives from various different iterations of demos that I've done for conferences. So I think going back to about 2015 was the first time I did anything with WebAssembly. And at that point, I was curious about, could I make .NET run on WebAssembly? And at that time, the answer was just no. I tried a bunch of things and nothing got me anywhere. I couldn't really get anything besides just C to run that way. But then when around 2017 rolled around, technologies had moved on. The Emscripten compiler for WebAssembly was a lot more capable by then, and people had been experimenting with doing stuff with Go and Swift and Rust and so on. So I decided to have another go at getting .NET to run on WebAssembly, and I still couldn't really make the full .NET runtime compile that way, but luckily I came across a very minimal .NET runtime called .NET Anywhere, written by a guy called Chris Bacon, and that was implemented in a very simple way, just as probably about 100 C files, and getting that to compile through Emscripten to WebAssembly was really straightforward. It was, literally like a 15-minute task to get as far as, printing "Hello World" to the console in the browser, which was amazing, like amazingly lucky. If it hadn't worked first time, I might have just given up and, gone and made some toast and forgot about it. But it did work first time, and so that was really exciting. And I think my personal history in web has always been quite UI focused, and so pretty much the first thing I thought of doing as soon as I could have .NET in a browser was make a UI framework with it. So that was the thing I prototyped and made into a demo scenario. And that original prototype was quite reflective of what the product was to become. I had things like hot reload in the very first demo, and the same sort of like component oriented programming pattern that we shipped. So I guess it came together very easily because it was so familiar to me because of all the other technologies that I was working on in that space.
Yeah, well, it certainly has taken off, and I think just the catalog of at TechEd and the Microsoft Build conferences and all the sessions and the technologies, and just the number of people now that are working in something Blazor related, and of course out in the industry. There are lots of people who are calling Blazor applications like the new normal, UI web application type, and of course it's so broad, but it could be an overstatement. But let's jump. There's so many things that are fairly new. People are thinking, oh, Blazor, okay, web applications. Oh, WebAssembly, I can run it in its own browser. Let me ask you specifically about the native dependencies, because I don't think a lot of people know about that. You gave a demo recently to a group running SQLite, which is not a .NET database, but SQLite in Blazor. How does that all work?
Yeah, so it works fairly naturally, really. So when you deploy a Blazor WebAssembly application, most of the time, or prior to .NET 6, there wasn't any native compilation process. We would just compile your .NET code to .NET assemblies, and then we would run it inside a runtime that Microsoft has already compiled for you. But the change that we brought in .NET 6 was some tooling as part of the MS Build-based build and publishing process that, as well as doing the .NET compilation, could also do some native code compilation with Emscripten to produce a different WebAssembly bundle than the one that we've built for you. So we've already got .NET compiled to, what is it? I suppose it's LLVM bytecode that ships inside the SDK. And then when you publish your application, we can do the final step of the transformation from LLVM bytecode into WebAssembly bytecode. And during that process, we can feed other native code into it as well. So if you've got myfile.c and you tell us to include that in the compilation process, well, that will get compiled and become part of the WebAssembly bundle that you have at runtime. And then if you take something like SQLite, well, SQLite is distributed as just one giant C file. So yeah, you can just include that in the compilation, and then all of its native exports become available to .NET at runtime. And then when you take something like Entity Framework, which already knows how to work with SQLite, it already knows how to load how to use those native exports, well, it just works because, it's the same exports that EF already knows about. Now, that I've made it sound probably more complex than it really is, because the actual usage experience for a developer is not think about native compilation. It's just reference a NuGet package, the end. Like, it's as simple as that now, because someone else has already done the work to create a NuGet package that contains SQLite and contains all the necessary build config for it. So you, the developer, don't think about that. You just reference a package, use Entity Framework, it just works.
And I'm thinking that one of the just slam dunk use cases is when I need to cache some significant amount of data that I don't just want to put in arrays or lists or some data structure, but if I'm pulling it, I can. Is it just as simple as initialize it and then use Entity Framework to lay down the schema the first time it loads, and then use regular calls?
Yeah, so it is regular EF APIs. There's no WebAssembly specific version of this. So you use the same things that Entity Framework has in terms of DB contexts and the initializers for that, and all the different patterns that you can have for creating and defining the shape of the DB context and the keys and the the indexes and all that kind of stuff. And that will result in it creating a SQLite database in the right shape. And then you can start loading data into it and do that stuff. And yeah, I definitely agree that in terms of usage scenarios, filling that up as a local cache so that you don't have to keep going back to the server all the time is really powerful. But I would also add that it enables other things besides just that. So it enables efficient client-side transformations and querying of the data. So if you've got like a megabyte worth of data, sure, you could hold it in memory. But if you want to then sort it by a certain property and take the items number 2000 to 3000, as long as they match a certain predicate or something, just constantly crunching through all those operations in CPU, in the normal .NET code, is going to make that quite an expensive operation. But if you have it in SQLite and you express that request as a SQL query and you've got all the indexes in place, and I found that very beneficial when I was, for example, trying to have a large data set and connect it to a rich grid that allows the user to dynamically change sorting and filtering conditions on that data. You don't have to worry about implementing logic to do all that efficiently. You just use Entity Framework APIs and trust that SQLite will give you the data in a very efficient way.
Yeah, that's amazing. And I think with SQLite, the memory it's using is in the browser. So are there limitations on how long we can have it live between browser sessions on a particular user's computer? That's kind of browser based, isn't it, at that point?
Yeah. So I guess the data is going to be stored in two places. So while it's being in use, it's going to be inside the browser's memory, inside WebAssembly. But you want it to persist longer than that, because if the user refreshes the page or closes their browser and come back, you don't want them to start from a completely fresh state again. You want the data to be persisted. So the way I've seen it done and the way I've done it myself is to periodically flush out the state of the database to the browser's local storage. Or if you want to, you can flush it out into IndexedDB in the browser. There's more than one persistent location in a browser you can use.
Nice.
And then it's there for as long as the browser lets you keep data there.
Another big announcement at the MS Build conference was, of course, Maui going GA, and I think at the conference, some of the tooling is still being worked on. Can you give us a sense with when it comes to Blazor and all the native capabilities, which parts are completely ready for just regular developers to use now, and which parts maybe still have some rough edges, some gotchas? like, weird differences between iPhone, Android? Or what's the state of that landscape at this point?
So are we talking about Maui here, or are we talking about Blazor specifically, or?
Blazor with Maui, it was announced, but
Yeah.
but also Blazor with WPF, I suppose, doesn't even need any of the Maui technologies, right?
Right, I see. Yeah. All right then. So yeah. So Maui has been the biggest focus for the Blazor team throughout .NET 7. We spent between about November and April or something being completely focused on that. And our primary objective, which, came down from higher up in the business, was we need to make this work really well inside Maui, because, Maui's the flagship thing here. And we need people who are doing these cross-platform applications who maybe prefer web development as a general pattern and are more familiar with, say, rendering UIs with CSS and so on. We need to make them have a really good, familiar developer experience, and preferably to be able to reuse code that they have from Blazor Server or Blazor WebAssembly. And, the same components should just drop in and work. So that was certainly our biggest goal. And I'm fairly sure we've achieved that, like, convincingly. And that's certainly 100% ready to go. That's in GA now. There's absolutely no reason why people shouldn't be building their important production apps on that technology. Along the way, we as a team independently thought, well, if we're doing that, couldn't we also make it work with WinForms and WPF? Like, we're doing all this work. It should be like a trivial thing to also wrap this up in a WinForms control and a WPF control. And we did that, and management said, cool, great. This is we still love our WPF and WinForms developers. Obviously, these are areas of active investment, so it's great to be able to give these additional options there. Now, in terms of, is that ready for production use? Yeah, I think it is, because honestly, it's really simple in terms of how that works. All the clever stuff is what we're already doing for Maui anyway. And the part of it that we've layered around it for WinForms is kind of trivial. Like, there's not really anything that's going to go wrong with that. The only way, I suppose, potentially, that you might face additional challenges is that it's a more niche scenario. So you might discover some obscure detail of something that's specific to WinForms, and then you'll go searching on Stack Overflow, and you might not find that other people have already hit it. Whereas Maui is perhaps a little bit more of a mainstream one. But right. I'm fairly sure that, all these technologies are ready for use.
Okay. I think there's plenty of people who say, oh, no, wait till the third version, the first version. But the piece parts of these, a lot of them are on the third version. They've just kind of been put together in a unique way, right?
Yeah, that's a fair way to look at it. So certainly the Blazor programming model and the tooling around that's not a V1 thing by now. It feels a sort of V3 level of maturity at this point, maybe getting on to V4. And that is the same experience that you're getting when you wrap it up in Maui. But the things that you do that are specific to native app development, that perhaps has more of a V1 feel to it. So let's take something like authentication as an example. You're in a Blazor web rendered piece of UI inside a Android application, and you want to make the user log in using, I don't know, Azure AD or something like that. The flow that happens at that point is quite unique to the fact that this is running in a Maui app on Android. And that doesn't have like a V3 level of maturity. That is a V1 thing, and it absolutely should work. But I'm not going to pretend that if you've got obscure requirements, it's always going to be effortless. Like, you probably don't have to work too hard to find something that is hard to figure out how to do.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
I'm still trying to wrap my head around the Blazor as a programming model and its method of using the kind of the same developer skills to make all kinds of different applications now, and then the WebAssembly portion, which
Yep.
is has its own train forward with WASI, which I'd like to ask you about as well. In your mind, how do you sort out what the path of Blazor is and what the path of WebAssembly and that family of technologies?
Yeah, I personally don't find that very difficult to distinguish, but I'm aware that this has been like in my brain for 3 years now, and someone coming into it from outside might see what looks like a tangled mess of terminology and just think, well, how am I supposed to know what's what in that, even though it feels quite straightforward to me. But the way I would characterize it is simply that Blazor as a term or as a brand is a UI framework. It's not a runtime. It's not WebAssembly. It's not Maui. It's just it's a UI framework for .NET that is optimized around using web technologies for rendering. So theoretically, you can even use Blazor without web rendering technologies, but we don't have any production support for that. So we could just say that Blazor is a web rendered UI technology for .NET, and it runs in multiple different environments. It runs on top of WebAssembly. It runs on servers with a WebSocket connection to browsers, and it runs in native desktop apps via Maui, which includes iOS, Android, Windows, and Mac support, or via WinForms or via WPF. But it's the same programming model in all these cases, and the same components, the same class libraries should just work, at least in 99% of cases. There are a few cases where you can do something that's platform specific, but as much as possible, you would not do that, and your component would work everywhere.
Okay. One of my teams found or learned that some of the earlier versions of Windows 10 don't include the WebView 2 component.
Oh, yeah.
So it was a simple system tray WPF application where the few screens that popped up, let's use Blazor. And it worked great, except on some computers. And then we had to put a startup routine that sniffed out the presence of WebView 2. But so that's the one where Windows 10, mostly, if it's updated.
Yeah, we want to make that a little bit easier. Ideally, the installer for WebView 2 should be chained into the installer for your Maui application, so that as part of installing the application, it's able to fetch WebView 2 if needed. And we would have liked to have made that a built-in feature, but delivery timescales were tight, and so that's not the case.
And it was an easy installation. Now, okay, so for WebAssembly, we talked about SQLite being available as a package for WebAssembly, and then of course it's a .NET NuGet package that we could pull down. But you've also done a lot of work around WASI for the for the listeners out there who are, okay, WebAssembly, I get it. Wait, WASI, what the heck is that?
Yeah, well, it's probably good to think a bit about the history of how we got to here. So WebAssembly as a technology was originally brought to life by Mozilla, who are, as people will know, are browser people or were, and that's been their historical focus. And that's the bytecode format that is designed to run in a highly performant but also incredibly strictly sandboxed kind of way. So it's always been designed around this idea that the code you're running might be hostile, and it needs to have the same level of defenses as you would have when you're running JavaScript in a browser. And in fact, the actual WebAssembly runtime is built into the JavaScript runtimes inside browsers. So that's that bytecode focused on browsers. That's the history of WebAssembly, and that's meant to have benefits like you can compile from any language you choose, and they should all be able to get into the browser in an efficient and performant way. But once you've got to that point of having this multi-language, highly sandboxed, highly performant way of running code, it's not a big jump to think, well, maybe we can benefit from that, not just in browsers, but also in terms of our server-side code as well. The ability to sandbox processes or individual function calls or collections of functionality within your application and be able to combine pieces that are written in different languages in an efficient way is obviously very appealing. You could think of it as a sort of a reinvention of some of the VMs that have existed in the past. So we've had the JVM, we've had the CLR. They're both virtual machines for running a special bytecode format. But a key difference with WebAssembly is the way that it's designed around the assumption that the code you're running is hostile in a much more complete way than has ever been done with, say, the JVM or CLR. .NET used to have this like app domains thing and code access security, but it was always a kind of like best effort. We sort of hope this will work kind of thing. And we eventually had to kill it because, people who are attacking you, they're not just going to mostly fit in with your assumptions. Like if there's any gap, they're going to get through it. Whereas WebAssembly is designed to assume like the most malicious possible intent and defend against that. So yeah, where we're getting to the idea that you've got this efficient bytecode format that can run on a server and give you a lot more flexibility in terms of how you roll out your cloud-based applications. You don't necessarily have to put each different piece of your application into a different container just for isolation purposes, because each WebAssembly module is isolated anyway. So you maybe get much better hosting density. You also potentially get much smaller binary payloads than you would with a container. It's very, very likely to be multiple hundred megabytes. Like theoretically, you can shrink it down to 60 megabytes or something, but nobody does because it's so much work. Like it's probably going to be 500 megabytes that you're moving around. And if that's getting deployed dynamically to multiple pieces of hardware, that's a non-trivial thing to move around. And then in terms of startup time, you're basically starting up a whole operating system every time a container comes up. Not exactly, but it's got significant amounts of overhead like that. Whereas with a WebAssembly module, instead of being 500 megabytes, it might be 15 megabytes. And the startup time, instead of being 10, 20 seconds, it might be 10 or 20 milliseconds. So, you have potentially a huge amount of additional flexibility to get a lot more code running on an individual server and take it down and bring it up really rapidly, depending on what's going on.
Now, when you say the word module, should we translate that into library that's in my process or a running process?
Yeah, it's closest to a running process today. This is going to change as time goes on. There's this whole thing called the WebAssembly component model that generalizes this a lot. But for WebAssembly as it is today, yes, a module is a unit of isolation and a unit of deployment.
Okay.
So it's like a process.
And so for the sandboxing, is it included where if I was to use a WASI library, is there also some isolation in between libraries, wrapping libraries, or just at the process level?
Yeah, so that actually gets us back to this component model concept as well. As it stands today, everything in a WebAssembly module is compiled together into one binary, and it all accesses the same memory space. So there's no isolation within your module. It's like anything can just read and write memory from anywhere, and that's fine because that is your unit of isolation. That's your trust boundary. But in the future, there's this concept called the WebAssembly component module, which is about bringing together multiple pieces of WebAssembly from different sources that might have been compiled in different languages, defining an interface for them to communicate with each other through function calls that are strongly typed, and then a way of defining to what extent they have separate memory spaces or share memory spaces. So you can reference a component and say, I'm giving it a reference to my memory so it can just do whatever it wants with it. Or you could say, I want it to create its own separate memory, and then I'll define this marshalling rule about how objects move across that barrier. And then that it can't do anything that you didn't ask it to. And that's also extends to things like capabilities that you offer. So when you instantiate your WASI module, you'll choose whether, for example, it's allowed to access the file system or whether it's allowed to access network. And if you say no, well, there's no APIs for doing that, it can't possibly do it. But if you choose, you give it access to those things. And then when it in turn instantiates another WebAssembly component, it chooses whether to pass through those APIs into it or whether it doesn't. So if your WebAssembly code is starting up some kind of like date formatting library, you probably wouldn't pass through the file system APIs for X. Why would it want to access the disk? And so you know for sure that it's definitely not going to touch the disk or whatever else that you didn't give it access to do.
Okay, so we're used to it on our mobile phones. Hey, this app would like to use the GPS, location services, and all. So this is at the library level, where if I'm going to use that library doesn't have access to anything outside the sandbox. And you mentioned passing in functions.
Yeah, that's right.
Does that mean that I, as the program who get to run as the user, I have access to everything the user has access to, but am I passing through a Lambda or a closure or something?
Yeah, basically. I mean, think of it as a Lambda or a function pointer or anything else, or just like a handle to a thing that you can call. So imagine that there's an API for listing the contents of a directory, which there is. Then your WebAssembly module, the top level thing, may or may not have access to that from the native operating system. And when you instantiate a child component, if you do have access to that, you can pass it through and then it can access the file system. But another thing you could do if you wanted was to define your own function that has the same signature and pass that instead. So now when it wants to read the file system, it doesn't know. It has no way of knowing whether it's reading the real file system or just some kind of simulated thing that you're giving it. So you could, if you want to, you can give access to stuff, but also instrument that for logging or other reasons. Or you could entirely simulate different system services, or you can just flat out deny access to them, whatever you want.
It made me remember of aspect-oriented programming or inserting, pre and post processing.
Yeah, it's like that. Or you could think of it as like dependency injection. Every time you create a new thing, you choose what implementation of the contract to supply to it. You could supply an implementation that is real in some sense, or one that's simulated, or some combination of the two, or whatever. But the thing that receives it can't know which it is. All it knows is that it's got a function that has a certain signature it can call.
Okay. So if I'm day to day, I write all my code in C# and I'm using the .NET ecosystem. I use NuGet. And of course, there's NPM for all the people who primarily do JavaScript all day.
Yep.
And I can't just reach over and use an NPM package without doing some kind of, adapting or whatnot. Do you think this is going to create a new package repository of WASI, or do you think that this will just make new packages that just get a regular .NET wrapper and then put into NuGet? How do you see this eventually playing out?
That's really interesting. I don't know that I've really thought that through in any detail, or to what extent other people have done. But yeah, I don't see any particular reason why you couldn't have a package repository of WebAssembly components that could be consumed from other languages. Now, if you are compiling from something like, if you're compiling to WebAssembly ultimately, whether you're coming from C# or Go or Swift or whatever, then of course it's expected that you should be able to use other WebAssembly components, because that's what the whole WebAssembly component model is for. But if you are not compiling to WebAssembly, you're just going to run on the CLR, or you're going to run some native code or something, I guess you could still use the WebAssembly components. I just haven't really thought about that before. You could. You just have to have a way of executing it, which is quite straightforward, because you can already run WebAssembly code inside .NET or inside Rust or whatever else, because there's a library for that called wasmtime, which already works on anything. Yeah. So yeah, I mean, it could be done.
Well, right now, and I've been programming since the mid '90s, and the industry has this huge divides up where there's people who do work, and even the open source work. There's JavaScript open source work. There's Linux. There's Java. There's C#, and it's like there's these big walls where I need a library that's written in C# or for C#. But does this really have the potential to bridge those divides, where all the great work that people are sharing can just be kind of cross-compiled and then used from all the different platforms, or is that going a little bit too far?
Well, I think that's very interesting. And my guess is, just based on history, that it might end up being a question of lower level things very likely can span different languages, and higher level things probably wouldn't, or they could theoretically, but it wouldn't really be what you wanted. So if you imagine something like say an image resizing thing, like that's just a really basic piece of functionality that it should work the same across every language. You could imagine an implementation in WebAssembly that's, performant, and then people would just use that with everything. But then you could also imagine a much higher level system like Entity Framework or ASP.NET MVC or something like that. These are really tied to .NET concepts and .NET idioms. They assume that they're going to have a really fine-grained awareness of how your application looks, of how data is represented and how they can do reflection over it and all that kind of stuff. It's very .NET specific. And I can't really imagine a JavaScript developer thinking, you know what, I'd really like to consume Entity Framework directly without any changes to its APIs. Yeah. And vice versa. Like you wouldn't want to take an Angular application and just call it from .NET, because so many of its APIs don't look or feel anything like .NET.
Right. Well, as we kind of wrap up and get to our time here, there's a lot we talked about, kind of spanned some really big topics. For listeners who kind of want to dig in and get the latest and start experimenting with the latest of these items that are actually available, where would you point them to just start digging in? Is there actual code samples that they can pull down and start playing with, or what would you say?
So if we're talking about where we started in this conversation with Blazor stuff, then I would be looking out for all of the .NET 7 preview blog posts that we release about once a month, because they always keep you up to date with what we've just shipped in current previews and give you access to download and try that stuff out. If we're talking about the WebAssembly on the server and WASI type stuff, if you're a .NET developer, I would suggest check out the experimental .NET WASI SDK, which I have got on GitHub currently. We'll probably move that into one of the Microsoft organizations fairly soon, but that's currently on my GitHub repo. GitHub user, I mean. And I guess those are the main things at the moment. There are other WebAssembly related things that you can look into and try out. Obviously, that we've got the Azure Kubernetes Service supports WASI workloads now. That's very much just an experimental thing to try and gauge interest and gain experience for us. I'm not sure. I would imagine in the long run, Azure would have WASI related services that look quite different from that, but that's where we're starting with understanding this space a little bit, so people can try that. And those are the main things I would say.
Okay, we'll make sure to include those links to those in the show notes for sure. All right. Well, Steve, hey, this is a very broad conversation. Lots of great information. I appreciate you coming back on the podcast to tell us all about the latest in Blazor and WebAssembly and WASI.
Awesome. All right. Well, thank you.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.